All right, so in this lesson, we learned how to not only convert between grams and moles and particles, but we combined it all together. And I used this diagram here just as a reference. You won't be given it on a quiz or a test, but I will use it when I'm going through and explaining these just so people will have an easier time visualizing the work that I'm doing. So for the first problem, it says how many molecules are in 38.52 grams of sulfur dioxide. So I'm going to start out, I have 38.5 grams of sulfur dioxide, and I want to get into molecules. So if you look at the diagram here, I'm in grams, I want to get into molecules, so I'm going to go from grams to moles first, then from moles into molecules. Okay, so I'm going to put grams on bottom, and I'm going to get into moles first. Then I'm going to go from moles, I'm going to get out of moles, and I'm going to get into molecules. Okay, so let's figure this out. Well, grams to moles, the conversion factor for this, to go from grams to moles or moles to grams, is going to be my molar mass. Well, I got to figure out the molar mass of sulfur dioxide. So sulfur dioxide, the formula for it is sulfur, 1 sulfur, and 2 oxygens. So then the molar mass for that, I'm going to take the molar mass of sulfur, 32.066, and I'm going to add to that the molar mass of oxygen, which is 15.999, multiplied by 2. And so what I get for the molar mass of sulfur dioxide, if I round to 2 decimal places, is 64.06 grams per mole. Okay, so I'm going to plug that in here. So it's going to be 64.06 grams for every 1 mole. Then for the molecule to mole conversion, I'm going to use Avogadro's number. So 1 mole is 6.02 times 10 to the 23rd molecules. Okay, so now I'm going to plug this into my calculator. 38.5 divided by the 64.06 molar mass times Avogadro's number, and I get, unrounded, 3.6178 times 10 to the 23rd. Okay. Keep in mind, I want to have 1, 2, 3 sig figs, 1, 2, 3, 4, 1, 2, 3. So my fewest number of sig figs is 3. So 1, 2, 3 significant figures. So this is going to be 3.62 times 10 to the 23rd. And my units are molecules. Okay. Let's look at the next problem. How many formula units are in 4.50 moles of sodium sulfate? Okay. So I'm going to first write out my given, which is 4.50 moles of sodium sulfate. Okay, and then I'm going to look at my diagram. I actually can go directly from moles into formula units. I don't have to deal with mass at all. So that's one thing people get confused about. As soon as they see molar mass, or they learn about molar mass, they assume they're going to have to use molar mass every single time. And that's just not the case here. I'm getting out of moles, and I can go directly into formula units. So this is actually just going to be a simple one-step problem. I know that 1 mole is Avogadro's number's worth of formula units. So I don't even have to write out the formula for sodium sulfate here, because I don't need to know its molar mass, because I'm not dealing with mass at all. So I'm going to take 4.5 and multiply it by 6.02 times 10 to the 23rd. And the unrounded value that I get is 2.709 times 10 to the 24th. However, 4.50 has 3 sig figs. Avogadro's number has 3, so I want 1, 2, 3. So this is going to be 2.71 times 10 to the 24th. And my units are formula units. Okay. So it's not always going to be a 2-step problem. So just keep in mind, moles are your central unit. So if you're converting into moles or converting out of moles, it'll just be a 1-step problem. Okay, let's look at the last one. How many grams are there in 4.5 times 10 to the 22nd formula units of barium nitrate? So 4.5 times 10 to the 22nd formula units. Let's look really briefly at my diagram. Okay. I'm going to go from formula units, first into moles, then for moles into grams. Okay, so let's actually do that. So formula units, I need to get out of formula units by putting it on bottom. Okay, and then I'm going to first get into moles as my central unit. Then I can get out of moles, and I'm going to get into grams. Okay, so Avogadro's number, 1 mole, is 6.02 times 10 to the 23rd formula units. In order to get into grams, I need to know the molar mass of barium nitrate. So I have to write out the formula for barium nitrate. Barium has a 2+ charge. Nitrate has a 1- charge. Okay, so the formula for this is going to be BaNO32. All right, so to determine the molar mass of barium nitrate, barium has a molar mass of 137.328. I have 2 nitrogens there, so it's going to be 14.007 times 2. Okay, and I have 2 because there's a 2 outside the parentheses there. And then I have a total of 6 oxygen, so 15.999 times 6. And so what I get for my molar mass of barium nitrate is 261.34 grams per mole. So I'm going to plug that in up top. So it's going to be 261.34 grams for every 1 mole. And so when I do out the math, I'm going to take 4.5 times 10 to the 22nd. I'm going to divide it by Avogadro's number, 6.02 times 10 to the 23rd. And then I'm going to multiply by my molar mass, 261.34. The value that I get, unrounded, is 19.535, let's say. Okay. However, I want 2 sig figs, 1, 2, 3, 1, 2, 3, 4, 5. So I want a total of 2 significant figures. Okay, so the 5 is going to round the 9 up, and the 9 is going to round the 1 up. So this will be 20 grams. However, I noted I want 2 sig figs, so it's going to be 20 grams, so that I have 2 significant figures.